Question 4.57. An engine block of mass M is on a flat bed of a pickup truck that is traveling in a straight line down on a level road with an initial speed of 30 meter per second. The coefficient of static friction between the block and the bed is 0.540. Find the minimum distance in which the truck can come to a stop without the engine block sliding towards the cab. So here in this question, you have a pickup truck. And on the flat bed of pickup truck, you have an engine block of mass capital M. And you need to find what minimum distance delta X the pickup truck must cover before it comes to a stop so that this block does not slide towards the cab. We have the initial speed of the pickup truck, which we will write as V0, that is 30 meter per second. We have the coefficient of static friction mu s, that is 0.540. And since the truck needs to come to a stop, its final speed will be 0 meter per second. We need to find what distance delta x it must cover so that the engine block does not slide on the flat bed. Now, if they have given you the initial speed and the final speed, and you want to find what is the displacement delta x, you can use the fifth equation of motion, which says that v final squared equals v initial squared plus 2a delta x. Delta x can also be written as a change in the final and initial position. We need to find delta x, so we rearrange the term, move v initial to the other side, so we get v squared minus v naught squared equals 2a delta x. Divide by 2a on both sides to find delta x. We get delta x equals v squared minus v0 squared over 2a. The final speed v of the truck is 0. So if I substitute this as 0, I get delta x to be equal to negative v naught squared over 2a. So I need to find what is the acceleration a in order to get the value of delta x. So we can write this as equation 1 and come back to it after we find the value for acceleration. To find acceleration, we need to find all the forces acting on the engine block. So the first force we will show is force due to gravity acting vertically down. We call it Fg. Then we have the normal force acting perpendicular to the surface. We call it N. And then we have the force of static friction that is preventing the engine block from sliding. We will call it Fs. And after we show all the forces acting on the truck, we will write the equation of net force both along the x-axis and y-axis. So let us start with writing the equation along the y-axis. The engine block is not moving along y-axis, so my acceleration along y would be equal to 0. So we can write F net along y to be equal to 0 as the block is not moving along y-axis. There are two forces along y. First is the force due to gravity acting vertically down, and then you have the normal force perpendicular to the surface. And by convention, we take any force going up to be positive and the ones going down to be negative. So I can write F net y as the vector sum of these two forces. And when I take the vector sum, I have to take their sign into consideration. So N will be positive and Fg will be negative, equals 0. You can move Fg to the other side. That gives you N equals force due to gravity Fg. And we know we can write Fg as m into g. Let me call this equation 2. Now we do the same thing for forces along the x-axis. Along x-axis, we have an acceleration a. So we write F net along x-axis to be equal to m into a. There is only one force along the x-axis, which is the force of friction. And this force of friction is going opposite to the direction of motion. So if my pickup truck is going to the right, the force of friction is going to the left. So we write this force of friction as negative Fs. Fs for the force of static friction equals m into a. Now we know that force of friction Fs can be written as coefficient of static friction times the normal force. And normal force from equation 2 we found to be equal to m into g. So I can write my force of static friction to be equal to mu s m into g. Let's substitute that here. I get negative mu s m g equals m into a. Cancel off the m from both sides. So A becomes equal to negative mu s g. Let's call this equation 3. Now, if you look at the sign on A, it is also negative, which indicates that this acceleration is also opposite to the direction of velocity, and it is in the same direction as the force of friction. So I can show my acceleration going to the left, opposing the motion of pickup truck, which makes sense because the pickup truck is eventually coming to a stop. Now we are going to substitute the value of acceleration in equation 3 to equation 1. In equation 1, we had delta x to be equal to negative v naught square over 2 into a. Substitute acceleration here. So negative v naught squared over 2 times negative mu s g. You can cancel off the negative sign here. That gives you delta x as v naught squared over 2 mu s g. Now let's substitute the values. V naught is the initial velocity, so you write 30 squared over 2 times mu s, which is 0.540, and g is acceleration due to gravity, which is 9.81. And when you solve this, you get delta x to be equal to 84.95 meter. So this is the minimum distance the pickup truck must cover before coming to a stop so that the engine block does not slide towards the gap.